Hi friends, I welcome you all to the course Marketing Research and Analysis. Today we will be continuing from our last lecture. So, in the last lecture we were discussing about covariance and correlation, right, where we understood the difference and similarity between the two. So, we realized that covariance and correlation is basically more or less the same, but correlation being a standardized version of the covariance, and it has got an advantage over covariance that it not only talks about the direction of a relationship, but also the intensity of the relationship. So, correlation has an advantage over the covariance, and you can compare it with any number of variables, right. But sometimes comparison in a covariance case becomes difficult because the units of the variables will be different in nature, as I had mentioned a case about, let us say, height and weight, where height is measured in the centimeter and weight is measured in kg, right. So, centimeter kg makes no sense. Similarly, height and in years. So, centimeter in let us say the number of the age of the person. So, centimeter and years makes a very odd kind of a combination. So, correlation rather what it does is it is the ratio between the covariance and the standard deviation of the x and the y variable. So, it becomes it rises between the -1 and the +1, right. So, and anything that you do that can be compared against each other. So, that is the advantage. But today we will talk about the little higher forms of correlation, which is very important, because in real life it so happens that two variables are correlated, but the presence of a third variable could affect the correlation, right. So, similarly we need to, maybe sometimes there is a situation where we need to suppress the effect of one variable and find out the relationship between two other variables. So, this case is called a case of a partial correlation, and when you have more than two variables, you do maybe a partial correlation or a multiple correlation, assuming all three are important. So, you take the multiple correlation, or you want to suppress one, let us say x, y, z. So, you suppress z and see the effect of x and y. So, in that case it is a case of a partial correlation. So, let us see what exactly it is. Partial correlation, as it says, is a measure of the strength and direction of a linear relationship between two continuous variables, right, while controlling for the effect of one or more other continuous variables known as covariates or the control variables. Although partial correlation does not make the distinction between independent and dependent variables, although it does not make, because in correlation we should not say, but going by the spirit of the study, there is actually a dependent and an independent variable, right. The two variables are often considered in such a manner, right, that is, you have one continuous dependent variable and one continuous independent variable, as well as one or more continuous control variables. One more reason behind this is because you see correlation and regression are very strongly connected. These two topics are very strongly connected. So, when you do regression, automatically we will see that we talk about the independent and dependent variable. So, that is why when you talk about correlation also, in spirit you do not talk about it, but then actually there is there is a dependent and independent variable which you understand, but you do not need to mention them, because you are only trying to find out their relationship, right. So, let us see this case. I want to study the relationship between fertilizer and the yield, right, how much crop is produced, but I am keeping the weather condition constant. So, assuming that weather condition is constant, right, I am trying to see the effect of fertilizer and crop yield, but in reality it might not be possible, because weather condition does play a role on crop yield, and it is not only fertilizer. So, right. So, when I want to see this effect of fertilizer and crop yield keeping the weather constant, that means different types of weathers, they are suppressed and kept constant, right. So, in this case is a case of a partial correlation, right. Similarly, the relationship between level of anxiety of a student and the academic achievement, right. What is the effect or the relationship between anxiety, the level of anxiety of the student and the academic achievement? And here we are assuming that intelligence is the controlled factor. So, we are controlling for intelligence, all students are more or less the same, right. Okay. So, let us now, after understanding what is partial correlation and the effect of partial correlation, we need to understand the assumptions that we need to follow, right. So, what are some of the assumptions? The first, you have one variable which is more or less a dependent variable and one which is an independent variable, and they are both measured on a continuous scale. So, this is and I think by now you understand a continuous scale which is measured as in a interval or ratio, right. Assumption 2, you have one or more control variables. For in the last case you had weather conditions, maybe soil quality could also be another control variable, right, which are also known as covariates, and they are these covariates are measured in a continuous again, right, variable. Okay, this is here measured on a continuous scale, right. These covariates basically, as it is mentioned here, you see, are variables that you use to adjust the relationship, right, between the two variables, that is your dependent and the independent. So, how it is adjusting? If my weather condition changes, what will happen? If my soil the condition changes, what will happen? So, I am controlling, these are my control variables. Assumption 4, there needs to be a linear relationship between all the three variables, the dependent, independent and the covariate. That is, all pairs of variables must show a linear relationship. Okay. So, x, y, x, z and y, z, all the three must show a linear relationship. Outliers should not be present, because we have understood by now that outliers can distort the statistical interpretations, right. Sixth assumption, your variables should be normally distributed. So, these are basic assumptions which we need for any statistical or a parametric test. Okay. Let us go to a numerical problem. It says that milk intake has an effect on body weight, but the age of a person has also an effect on the body weight. So, now a researcher wants to see the relationship between intake of milk, body weight and the age of a person, right. In the first case, so what we are doing, we are trying to find out the correlation between milk intake and body weight while controlling for age. Just imagine that this is ought to be happen, because if you let us say intake milk, suppose we say body weight is let us say growing, improving or increasing, right, and if we take the body weight of several people and take their milk intakes, we can correlate them, we can find out some, we can draw some inference. But if we omit or we somehow we do not take into consideration the age of a person, that would be a very wrong interpretation, because the age of a the body weight of a person also changes with growing age, right. As you go up, as your age grows, generally your body weight tends to grow until unless you have some some negative health effect or something, some disease or something, your body weight goes down. Otherwise, with age naturally the body weight increases. Okay. So, we will see how milk intake and weight are related, keeping the age as a factor which needs to be controlled. Okay. So, this is the value, right. So, 10, 13, 19, 16 it goes on, this is the intake of milk, right, this is the weight of a person, right, and this is the age of the person. So, how do you find out, right. So, if you see, this is how, these are the formulas, right. So, we are finding out three different formulas. So, first what values we need, let us see. So, first to find out this, you need a relationship to find out the relationship between x and y, you need to find out the relationship between y and z and x. Three relationships can happen. Okay. So, what is the formula for let us say x and xy? So, it says x minus x bar into y minus y bar divided by root over of summated value of x minus x bar square into summated value of y minus y bar square. This is for x and y. Now, taking for y and z, x y, y z. So, you see what is happening, instead of here what you had x minus x bar, you are having y minus y bar, and instead of y minus y bar you have a z minus z bar divided by, instead of this x you are having a y and instead of a y you are having a z. Similarly, you can make it for z and x. So, for z this will be z, this will be x and this will be z and this will be x, right, other things remain the same. So, now we have taken this, let us say x minus x bar. So, x is my this much. So, x bar is 171 upon 9, 1 2 3 4 5 6 7 8 9, 9 respondents or values are there. So, divided by 9, so 19 x minus x bar, right. So, 10 minus 19 minus 9, 13 minus 19 minus 6, 19 minus 19 0, it goes on. Similarly, y minus y bar, what is the y bar? 43.889, right. So, we have done it. Okay. Similarly, z age, So, we have seen the 297 and the mean is 33. Okay. So, we have found out x minus x bar, y minus y bar and z minus z bar. Now, we need the x minus x bar square, right. So, x minus x bar square is 81, 36 and goes on, and this is the total, right. Similarly, for y minus y bar the total is this much, z minus z bar the total is this much. One more product we require, that is, you look at this formula. So, this x minus x bar into y minus y bar, similarly for others. So, x minus x bar into y minus y bar. So, how much is this? So, minus 9 into y minus y bar is 14 point whatever it is. So, if you multiply this, it will be roughly it is 134, let us say. So, minus 6 into 10.889. So, this is something around 65.3, it could be little more also, we can 65, it is okay, it is okay. So, this is 0, right. So, we have found out for x minus x bar into y minus y bar, similarly y minus y bar, z minus z bar and z minus z bar into x minus x bar. So, all the required values are there with us in our hand right now. Okay. Now, let us calculate the individual correlations. So, for the first case, the relationship between x and y is equal to 0.5323, the relationship between y and z is this much, relationship between z and x is this much, right. So, the partial correlation coefficient formula is now. So, what we are saying, we need to find out the relationship between, let us say, x y controlling z. So, the formula is this much, is this one now. This is equal to the relationship between x and y minus y and z into z and x. So, x and z or z and x whatever, right, by divided by root over of 1 minus r square yz, right, into 1 minus r square zx, right. So, when we use this formula, we will find that the partial correlation with which we get is equal to, by using that formula, you see you have calculated here 0.1283. So, this is the partial correlation. So, that means when we are trying to find out the change in weight due to the intake of milk by suppressing or by controlling the age factor, we see that the partial correlation is coming 0.1283, right. So, the interpretation is that the analysis reveals that there is a moderately positive correlation between milk intake and body weight while controlling for age. Now, just imagine, this is very important because sometimes we need to when we are looking at several relationships, correlations in our own research study, we need to partial out or suppress sometimes some of the variables that might impact, but then we want to suppress it, that we want to say ki we do not want to consider it, right, and see the effect of the relationship between the other two variables. Okay. So, this is the case of the partial correlation. Now, how you can conduct a partial correlation in SPSS, I will show that also. So, otherwise what happens, many times students face a difficulty that they understand through, okay, now by hand how to do it, but now how to do it on the SPSS, it is a problem. So, this is the case. A researcher wants to know whether there is a statistical significant relationship between Vo2 max. What is this Vo2 max? I will explain here. Maximum oxygen uptake and a person's weight, right. Furthermore, researcher wants to know whether this relationship remains same or not after accounting for a person's age, right. That means, is this relationship influenced by a person's age or not. Now, what is this Vo2 max? You see, it is the maximum oxygen carrying capacity, or is the measurement of the maximum amount of oxygen a person can utilize during intense exercise. So, see, the utilizing ability of a person, the utilizing ability of the oxygen varies from person to person. It has been seen that people who live in the mountainous regions, they have a higher efficiency in using this oxygen, right. Therefore, the researcher uses a partial correlation. Obviously, you have understood now, okay, well, I want to check the effect of these two by keeping the age as a factor, controlling factor. So, while controlling for age, now how do we do it? So, the steps are shown to you here, but I will directly go and show you on the data set that I have brought. So, this is the data set, same data set that we have been talking about. Okay. Now, how do I go? First I go to analyze, right, and now I go to correlate. Now, you see there is bivariate, partial and distance, but Distance is a case which is not necessary to be discussed now, we will talk about when we will talk about cluster and all, we will talk about it. But now we want to talk about bivariate and partial. So, what is bivariate? When two variables we want to find out, but here our case is a special case where we want to find out the relationship between not 2, but the relationship between 2 keeping the third as a control variable. So, what is my 2 variables? Now, variable is milk and weight, right, but what do I want to partial out? I want to partial out the controlling for the age. So, I want to control for the age factor. So, age factor, which generally we know that with age weight increases, that we are taking as a control variable. Okay. Okay. Now, we are taking this 0 order correlation and mean, right. So, these two we will take and see what is the effect now. So, let us go to the output file. 0 order correlation means, understand, there is no correlation any other variable affecting it, right. So, age, the relationship between correlation between milk and age is how much? You see is 0.416. When we take out, this is the partial factor. So, we are controlling this age. So, we want to see the relationship between milk and weight. Milk will be obviously 1, milk and weight you see is 0.416. Okay. Similarly, the weight and milk also will be the same because it is 0.416. Now, the significance value, look at the significance. Now, it is saying 0.048. So, that means what we are saying, that means it is a significant relationship. That means the relationship is when it is less than 0.05 or 5%, then we say that the null hypothesis is rejected. So, the null hypothesis is that there is no effect of age, the controlling factor age, on the intake of milk over the weight of a person. So, this hypothesis is now rejected, and we will say no, well, age does play a role, has a role in affecting the relationship between milk and weight, which are positively related, right. So, this is what actually it means. Okay. Now, let us go back to the slide and see. So, this is how we had done. So, we have taken the variables, right, and okay. So, I have written here, it indicates that nothing has been controlled, 0 order means nothing has been controlled or partialed out in an experiment. They are any correlation between two variables where no factor is controlled, it is a normal correlation, right. So, we have done it, and suppose you want to write, how do you write it? Now, interpretation, this is the way you write. So, whatever you have got, that is you can write that also. The descriptive statistics shows that we had no missing data, right, no missing data, 100 cases were there, and n is equal to 100 is the same number of participants that took part in the study. We can also see that the mean value, this mean value of the dependent variable was 43.63, right, with a standard deviation of 8.57, while the mean weight of participant was 79.66 or 7 with a standard deviation of 15.1, and finally, the mean age of the participants was 31.1 with a standard deviation of 9.1. This suggests that the sample of participants was slightly on the younger side rather than representing the population as a whole, because it is 31, right, which is useful to know when discussing the generalizability of the findings in your report. Now, you see, this is what we were checking there also. Now, how I am writing? The results of the partial correlation highlighted by the red rectangle show that there was a moderate negative partial correlation. Why moderate negative? This value is minus 3.14, right. So, negative partial correlation between the dependent variable Vo2 max and weight while controlling for age. So, this is how you write in your research paper or your report, right, which was statistically significant. Now, see how I am writing R 97. Why 97? You see here the degrees of freedom is 97 is equal to minus 0.314, n is equal to 100, no missing values are there, at p is equal to 0.002, right, p is equal to 0.0 significance value, right. However, when we refer to the Pearson's product moment correlation, also known as the 0 order or the simple correlation, without controlling for age as highlighted by the blue rectangle. So, here this is the blue rectangle where the 0 order correlation is taken, there is no effect, right, without controlling anything, age or anything. We can see that there was also a statistically significant moderate negative relationship between Vo2 and weight. So, look at it. So, 98 degree of freedom right, and the correlation value is minus 0.307, right, and it is significant also, it is also significant at 0.002. Can you see this Vo2 versus weight, right. This suggests that age had very little influence, 9%. Why I am saying 9%? If you see 3.3 is the relationship. So, if R is my 0.3, what is my coefficient of determination? R square, which is equal to 0.3 into 0.3, that is equal to 9%. So, only 9%, you need not write this part, but just is to understand. So, had very little influence in controlling for the relationship between Vo2 max and weight. So, we will suggest that it had an influence, but the influence is very little. Age had a very little relationship influence on the relationship between age and weight and Vo2 utilization, oxygen utilization. Okay. So, again writing the same. So, a partial correlation was run to determine the relationship between an individual's Vo2 max and weight while controlling for age. There was a moderate relationship between Vo2 max. So, this is how you write the data from there, and weight this much while controlling for age like this, which was statistically significant at this, right. However, this is necessary, 0 order correlation showed that there was a statistically significant moderate negative relationship between this, indicating that age had very little influence in controlling for the relationship. So, when I see the difference between by taking the age and by not taking the age and I compare, obviously I can see the effect. Okay. So, this is what we do, right. So, now from here we will move into the next, which is the multiple correlation. So, now we are not talking about partialing out or suppressing or controlling anything. So, we are moving into a third condition. Multiple correlation deals with a situation in which the correlation between 3 or more variables are required to be found, at least 3 or more, right. Example, a farmer wants to find the relationship between yield of wheat per acre, amount of rainfall and the average daily temperature. So, he is not partialing out. So, he is not controlling anything, right. So, he wants to take all the 3 variables and want to see what is the relationship at one time, at one point of time, what is the relationship. Similarly, a military organization wants to find out the association between height, weight and age. Okay. Now, take this example. A study shows that IQ, study hours and annual grades are related. Okay. A researcher wants to find out the correlation among IQ, study hours with annual grades. So, it is a clear case of multiple correlation. However, if somebody would have said, okay, let us take the study hours as a control factor or something, then it would have been a partial correlation. But here we are not taking anything, controlling anything, but we are taking all the 3 at the same time, right. So, my IQ is given of some students, the number of hours they put per week is given and their grades or percentages are given. Okay. Now, how do you do that? Same way, right. So, let us find out. So, I am finding out R x y, R y z, R z x, okay, and then we use this formula, the overall correlation formula. So, this is R square of x z, R square y z minus 2 R x y, y z, x z, all these are individual the relationships between 2 variables, okay. This is x y, y z, z x, okay, and 1 minus R square x y, right. So, now using this formula, we will come back and see, we have done it earlier also. So, let us just look at it. So, same if you remember, so these values are more or less the same. So, 346, 133, these are same, right. So, we have used the same, that means the problem again, right. So, by calculating it, we have found out R square, the multiple correlation coefficient is equal to 0.82. So, if my correlation is 0.82, what is my interpretation? The study found a strong positive correlation among IQ and study hours with annual grades, right. So, what was it? You see IQ, x is IQ, y is my study hours and this is my grade, right, grade. So, what I am saying, study found a strongly positive correlation among IQ and study hours with annual grades, right. So, this is all we have. Now, let us see solve the same in SPSS also. So, I have brought one more data set for you. Now, this is the same case. So, IQ, hour and grade, and now we want to do a multiple correlation. Okay. So, let us go to correlation. So, if you do correlation, then you can do it. Let us say I want to go to bivariate. Now I will take all the 3, right, since I am not controlling anything, I take all the, you can see this is the Pearson's correlation, right. Why Pearson's correlation? By this time you should be aware that this is a normally distributed data. You can even check the normal distribution individually of the variables, and then you should move ahead. And please kindly check all the assumptions that are required, they should be intact. Okay. So, I do not need anything else, I am going with this, right. Okay. Now, let us look at the output. So, what is the output? Now, here we have a correlation. First look at the descriptive statistics. The mean of IQ is 18.7, hours is 49.5, grade 30.6 and standard deviations are given. So, there are 24 cases total. Now, the correlation between IQ and IQ will be 1. IQ and hour is how much? 0.614, and IQ and grade is 0.772, and you can see they are star marked. Now, it is star marked means what it is saying? If it is 2 star, double star, the correlation is significant at 1% or 0.01 level for a 2-tail test. Similarly, the correlation is significant if it is 1 star. Is there any 1 star here? You see this one is 1 star. So, hour and grade, the relationship it is 1 star, that means it is significant at the 5. This is the way of only marking something, coding something, right. This is 5% or 1%, right. So, now look at it. So, IQ and hour 0.614, it is significant. IQ and grade, the relationship is also significant at a 1%. Hour and IQ we have done. So, hour and grade remains. So, hour and grade is also significant, but this is significant at a 5% level of significance. So, when you write this, so this is the way you interpret the data and you write the inference in your research report, right. Now, but we want to suppose find out the overall multiple correlation value, right. So, what do we do? So, let us go back to the file and go to analyze and go to regression and linear. Now, what I will do is I will take my dependent variable as what? Now, weight, okay, and milk and age are my independent variable, okay. So, I do not need anything else. So, I will keep things constant, I will just go for it. Now, let us look at the output file. Now, if you look at the output file, you can see that when we have taken, right, this R tells us the relationship, the overall relationship between, right, the age, milk and weight, okay. So, this is of importance to us, this value R, right. So, this R basically in some we explain it in regression as the unexplained variance, that explained variance, but in other terms we say this is the correlation that we are talking about, the overall correlation, right, is 615. So, the model has a correlation of 615, that means 61% of the variance is explained and it is the overall model, right, the correlation coefficient. So, this is what we had today, right. I hope you are clear with the concept of partial correlation and multiple correlation. So, partial correlation you will use when you want to suppress or control some factor, some variable, and multiple correlation you will do it when you want to find out the relationship between 3 or more variables at the same time without controlling any one of them, right. So, this is the overall way you have to understand, and then this is how you have to write the interpretation in your research paper, right. I think this is clear to you, and this is very vital because this is highly helpful for getting a good publication and for making the readers understand what you have actually done in an experiment, right. So, thank you very much.